This video is on writing chemical formulas for binary ionic compounds. Again, these are ionic compounds, meaning there's a metal and a nonmetal. Binary means there's only two elements involved. You could have multiple atoms. Okay, so here you have two atoms of cesium, one atom of sulfur, but there's just a metal and a nonmetal, just two different elements involved in that, not three or four different elements involved. You could draw the structural formula like we were doing before. So like rubidium and iodine, you could draw the dots. You'd say, okay, rubidium's got one valence electron. Iodine's got 7. And go, okay, well, it just takes one of each, so the formulas are RBI. An easier way to do it is look up the charges and make the charges equal, because the charges, again, are made by gaining or losing electrons. So if you look at rubidium, it's in family 1. Those all have one valence electron. They tend to lose that electron and form a +1 charge. So rubidium's charge is a +1. Iodine is in family 17. They have 7 valence electrons, tend to gain 1 electron. Charge is -1. So we want the charges to be equal. In that case, they are, so it takes 1 rubidium with 1 iodine atom to react. Barium and chlorine. Barium is in family 2. It forms a +2 charge. Chlorine, same family as iodine, it forms a -1 charge. So for the charges to be equal, it would take 1 barium atom with 2 chlorine atoms. Each chlorine is a -1, so that gives you a -2 with the +2 of barium. Lithium and selenium. Lithium is a +1 charge. Selenium has 6 valence electrons. It is a -2 charge. So we would need 2 lithium atoms to make a +2 and 1 selenium atom. Compound's name is lithium selenide, barium chloride, rubidium iodide. You change the second element's ending to "ide." Nitrogen, magnesium. It's written backwards, so you always put the positive first. Magnesium's charge is a +2, so the first element will always be positive. So magnesium will be our first element. It's always the metal. The metal's always written first. I apologize for the big shiny dot in the middle of the paper here. Nitrogen is a -3 charge. It's got 5 valence electrons. Okay, I'm gonna write my formula down here so you can see it. But you would write Mg and N. Well, we need to get these to 6. So to make this a +6, we would need 3 magnesiums. To make this a -6, we would need 2 nitrogens. If you look at all these, notice that the numbers have just kind of switched. The charge on barium is how many chlorine atoms we need. The charge on chlorine is how many bariums we need. Okay, so the numbers have kind of switched a little bit. I'll leave those examples for now. In terms of writing names of them, okay, writing names, erase here. Actually, I'm going to go down to the bottom of the page and look at these. So here's some more formulas to write. Notice that some of these have Roman numerals with them. Okay, and Roman numerals are used when an element is a transition element, so in the D block of the table, because they can have multiple charges, or when an element is tin or lead. So a transition element and tin and lead will have Roman numerals. So these ones I've written charges in for would usually have a Roman numeral with them, but notice a lot of these have Roman numerals. So let's do a couple with Roman numerals. Roman numerals actually make it easier. So if we see mercury 2 oxide, that 2 tells me the charge on mercury is a +2. So I don't have to look it up. I do have to look up oxygen's charge. It's a -2. Okay, if those are equal, we need 1 mercury, 1 oxygen. Okay, if there's no Roman numeral, I look up charge. Calcium's charge is a +2. Nitrogen is a -3. Again, if it's 2 and 3, I have to get them to 6. So to get this to +6, I would need 3 calciums. To get that to -6, I would need 2 nitrogens. Look here, uranium, Vi is a 6. That means uranium's charge here is a +6. We're not really talked about yet how that happens, but I will show you that at some point in time. It's a +6. Fluorine is a -1. So we have here, we have a +6 with that, -1 here. We need to make this a 6 to make that a -6. So it's UF6. If you look over here, I'll do a couple of these again. Lead here is a 2 charge. Lead can have a couple different charges. It can be a 2 or a 4. So lead will always have a Roman numeral with it. That 2 tells you its charge is a positive 2. Look up chlorine, which is a negative 1. Lead is a plus 2. This is only a negative 1, so we need a couple of those to equal out the charges. I'll go down here. Tin, 4 fluorides. That means tin in this case is a 4 charge, positive 4. First element's always positive. Second element always negative. Fluorine's negative 1. So we need 4 fluorines to get a negative 4, and 1 tin is a positive 4. So transition elements will have Roman numerals to tell you where the charge is because they have more than one charge. Main group elements will not have Roman numerals because their charges stay pretty consistent. All right, let's go back up the middle part of this, and let's name some of these. So writing names for them is not real difficult. Sorry, my paper's a little bit sideways. So writing the names of them, just write the name of the first element. So CS is cesium. The 2 right there does not make a difference to you. Okay, it doesn't make a lot of difference. Paper's still pretty crooked. And then write the name of the second element, but change the ending. So sulfur becomes sulfide. Okay, sulfur becomes sulfide in that case. If I'm writing barium, so write in barium, change oxygen to oxide. Okay, this is aluminum, change iodine to iodide. Again, the numbers of atoms that are there does not matter. Notice I've got these 3 marked. Okay, and then this one, this one, this one. Those all have something in common. Those all would need a Roman numeral with them because the first element is a transition element. So we have to tell what charge is on that transition element. So let's do some of those. So Mn is manganese. Okay, and O is oxygen. I'm going to leave a space to put the Roman numeral in there. So it becomes manganese oxide. Here's how I get the charge on manganese. I look up oxygen's charge because oxygen's charge never changes. Oxygen is always a negative 2. Okay, each individual oxygen is negative 2. But we have 2 oxygens, so total would be a negative 4. Each oxygen is negative 2. There's 2 of them, so it would be a negative 4. That means manganese must be a positive 4 to equal that out. So the Roman numeral is IV. I'm going to skip this one. Let's go down here. CD is cadmium. And Br is bromine. Again, cadmium is a transition element, so we have to include a Roman numeral. Bromine becomes bromide. Again, look up bromine. Bromine is a negative 1 charge, but there are 2 bromines. So that the total charge there is a negative 2. That means that cadmium must be a positive 2. So the Roman numeral is a 2. Remember, the Roman numeral tells you the charge on the first element. Okay, charge on the first element. Let's go up here to, let's do this one right here. Cobalt is Ca. Again, it's transition element, so it needs Roman numeral. N is nitrogen. Nitrogen becomes nitride. Cobalt nitride. Probably can't see that in the video. The Roman numeral on cobalt. So we got to look up nitrogen's charge. Nitrogen is a negative 3 charge. That means cobalt in this case would be a positive 3. Let's go right here. Nickel. Okay, nickel's transition element, so we're going to need Roman numeral. Phosphorus becomes phosphide. Again, I apologize, probably going off the video there, but it's phosphide. So in this case, this one's a little bit different. Okay, a little bit different here. We have if I erase these. So nickel phosphide means you have nickel, 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 3 nickels with phosphorus and 2 phosphoruses. Okay, we want to know the charge on each of these individual nickels. So look up phosphorus's charge. Phosphorus is a -3 for each one. So that's a total of -6. That means this side has to be a +6 total. So each nickel must be +2, +2, +2. So the charge, the Roman numeral here is a 2. That's the charge on the individual nickel. So again, transition elements plus metals in the carbon family. So tin and lead in the carbon family need to have Roman numerals.